electric field on any general point P, okay, due to dipole. This is your heading. Electric field on any general point P due to dipole. Okay.
Yes, sir.
Yeah. First of all, we are going to draw the diagram of this dipole. Okay. Suppose this is your dipole. And this dipole is of length. Sorry. Yeah. This dipole is of length 2a, you can say. This is of charge minus q, and this one is the charge of plus q. There is any general point P where we want to calculate the electric field due to this dipole. And this point P makes an angle theta from the dipole. Okay, I mean from the center of dipole, you can say. This is your angle theta. The position vector of this dipole is r. If this dipole makes this angle of theta, then we can draw the component of this dipole in such a way that this is your another component of the dipole. Okay. And it is said to be the P cos theta, and it will be P sin theta. Are you understand it or not? This is your point.
Yes.
O. All right.
Yes, sir.
Now we have already know the two equations of the E axial and equatorial, which are E axial is equal to K into 2P cos theta over R cube, and E equatorial is equal to K into P sin theta over R cube. Okay. What will be the resultant field? The resultant field will be E is equal to E axial square plus E equatorial square plus 2E axial E equatorial into cos theta. Okay. I
Yes,
hope
sir.
you are understanding about this equation. This is the equation of parallelogram law. Do you remember or not?
Yes, sir.
Finally, we can write here E is equal to E axial is K 2P cos theta over R cube square plus K P sin theta over R cube square plus 2 into K 2P cos theta over R cube into Kp sin theta over R cube into cos of 90 degree, because the angle between E axial and E equatorial is 90 degree. Okay. So we are taking here
Yes, sir.
theta is equal to 90 degree. And now E is equal to, you can look at here, Kp over R cube can be taken as common from this and this term. Kp over R cube can be taken
Yes,
as
sir.
common. Okay. And now in bracket we have,
Yes.
1 second. In bracket we have P cos theta over R cube whole square. Sorry, not P cos theta. It is it is 2 cos theta, right? 2
Yes,
cos
sir.
theta over r cube, right? Plus
Yes.
sine square theta.
Sine square. Plus
Plus
2
this is the
cos
cos 90. Cos
100.
90 is 0.
0.
So this part will be 0.
But yeah.
Okay. We can take it. Finally, E is equal to Kp over R cube can be taken as outside
Yes, sir.
in
Common.
bracket. It is a 4 cos square theta. Sorry.
No,
One
sir.
second. This is not R cube also. R cube is also taken as common here. 4 cos square theta plus
Sine square.
square theta. Okay.
Yes, sir.
And we have already know this equation is in the terms of sine and cos functions.
Cos. Yes.
So we are going to convert it in any one of these functions, either in cos or in sine. So we have already know sine square theta is equal to 1 minus cos square theta. If you try to put this value in the equation, you get Kp over R cube root of 4 cos square theta plus 1 minus cos square theta. Okay?
Yes, sir.
Put it down, please. Then we will continue it.
Yes, sir.
Have you noted it?
So 1 minute. So done, sir.
Right. Now we have P is equal to Kp over R cube root of 4 cos square theta, right?
Yes, sir.
4 cos square theta, and in bracket we have
1 minus cos square theta.
square theta. This is a last equation. Yeah. Okay. So we can
Yes, sir.
write here also Kp over R cube root of 4 cos square theta and minus of cos square theta. It will be 3 cos square theta plus 1, which is your E. This is the final equation of
Yes, sir.
the electric field at any general point. Okay.
Okay.
Now from this equation, this is a this is an equation for any general point. From this equation, we can calculate the E axial and E equatorial also. Okay. Just let's try to understand it. If you take any point on the axial line, then we can say that this point makes 0-degree angle from the center of the dipole. Am I right or not?
Yes, sir.
Okay. This is your minus q and this is your plus q. Oh, sorry. Yeah, this is your plus q and the theta is equal to 0. Okay. If theta is equal to 0, then when you put this value of theta is equal to 0 in this equation, then what will you get? Kp over R cube root of 3 cos square 0 plus 1.
Plus 1.
1. Okay.
Yes, sir.
Cos 0 is 1. Finally, you get Kp over R cube root of 3 plus 1, which is 4.
Which is 4. Yes. 4 is 2.
E is equal to
K. Oh, yeah.
over R cube, right?
R cube. Yes.
This is your E axial. Okay.
Yes, sir.
And in the next part, we can write here, if you are taking an equatorial position, like this is your dipole, and you are taking at any point here, this makes 90-degree angle from the center of the dipole. Finally, if we consider theta is equal to 90 degree, when you put this value into this standard equation, what will you get? You get Kp over R cube root of 3 cos square 90 degree plus 1. Cos square 90. I mean cos 90 is 0.
0, yes.
Okay.
So it will be 0.
No. It will be Kp over R cube. 1 second. Kp over R cube root of 0 plus 1.
Yeah, root of 0, sir. Not
So
the
it will be E is equal to Kp over R cube. This is your value of E equatorial.
E
Okay.
equatorial, yes, sir.
And we can easily calculate from this equation the value of E axial and E equatorial. All right. So
Yes, sir.
note it down, please.
Done, sir.
Right. Now we are taking a question to, okay, understand it. This is your question. What is the magnitude of electric field intensity due to a dipole of dipole moment (2 into 10 raised to the power minus of 8 coulomb meter) at a point distant 1 meter from the center of dipole. From the center of dipole. The line joining the point to the center of dipole makes an angle of 60 degree with dipole axis. Note it down, please.
Yes, sir. Done, sir.
Okay. Now, can you solve it or not?
So,
This is a dipole of minus Q charge, and this one is of
plus Q,
plus
sir.
Q charge. There is a point P. Okay. And this makes an angle of 60 degree from the center of the dipole. Are you clear?
Yes, sir.
The separation of point P from the center is 1 meter, which is given in your question here. You can look at here, distant 1 meter. All right.
Yes, sir.
Now, what is your equation? The value of, what is the given values? The
Given
given
value, sir,
values
dipole moment is 2 into 10
are
raised to
is 1 meter.
Yeah.
Dipole moment, which is P. P is
2 into 10 raised to minus 8.
10 raised to the power minus of 8 coulomb meter. Okay.
Coulomb. Yes.
Then what is the value? E is equal to K. P
Kp
over
by R cube. Root
root of 3 cos square
3
theta
cos
plus.
theta plus 1.
What is the K? K is 9 into
9 into 10
10
raised to 9.
and P is your
P is 2 into 10 raised to minus 8.
power minus 8. R is your
1 cube.
root of 3
60
cos
degrees.
square 60
Cos 60
plus 1.
plus 1.
When you calculate this, 9 into 2 will be 18.
80. And then,
And
sir,
10 raised
it
to
will be
the power
minus.
9, 10
It
raised
will
to
be
the power
1.
minus 8 will be
1.
10.
Yeah.
1, you can left it.
Yeah.
Cos 60. Cos 60 is 1 by 2.
1 by 2.
After squaring
3
it,
into 1 by 2
1
plus
by 4. Okay.
Yes, sir.
Plus 1. Hence, 18 into 10 will be 180.
Yes.
And root of it will be totally 7 by 4.
Yes, sir.
You can take 4 as outside. Then it will be 2 180 over 2 root of 7. 2 is cancelled, 180. Finally, it will be 90 root of 7. This is your final answer. And what
Sir,
is the unit? Newton per coulomb.
Newton per meter.
Yeah.
Sir, I solved till 180 root of 7 by 4.
Sorry?
I solved the answer till 180 into root of 7 by 4.
Yeah, you want to solve it? This
No,
part.
I solved. I already solved.
Okay, all right, all right. Your answer is same or not?
Yes, sir. No, like
Okay.
I solved it till 187 by 4, so I didn't know how to do that. And then I told.
It's noted or not?
Yes, sir, noted, sir. Already done, sir.
Okay. Then we should move on.
Yes, sir, yes.
Now, before starting the next topic, okay, we are going to remind some basic fundamentals of the vectors, okay, which is mostly used in that topic. All right.
Yes, sir.
I hope you have remember about the cross product.
Dot product, cross product, yes.
Okay. What is the cross product? The formula of cross product is if the two vectors are acting at particular angle theta in such a way that then vector A cross vector B will be mod A mod B sine theta of unit vector n. Okay.
Yes, sir.
Where neta, what is the neta? Neta
Newton.
shows direction of A cross B. Of A cross B, which is perpendicular to both A and B. Okay.
Yes, sir.
And what is the rotational motion? Do you remember? In
Yes, sir.
rotational motion?
Like the chapter of 11th.
Yeah. In rotational motion, there are some other quantities which is also important to remember here. The first one is the torque.
Torque, yes.
What is the torque? Torque is the rotational
It is the amount of
analog.
force, additional force there.
Okay. No. Rotational analog of force, right?
So what is the meaning of analog?
I mean, when you are acting an external effort upon a body, okay, if
Yes.
it start to move in a horizontal or in a straight line, you can say, or you can also say in one dimensional motion, then the acted effort is said to be the force. And when you apply a force upon a body, okay, causing which the body start to rotate about a fixed point, just like while opening the door. Okay.
Yes, sir. Yes,
Yeah.
sir.
You are
That's
pushing
translational motion.
by handing the knob of the door, okay, causing
Yes.
it to start to rotate. Then the applied
Yes.
force by you said to be the torque. Are you clear or not?
Yes,
so we
sir.
can say the torque generates rotational effect. Are you clear?
Yes,
or
sir.
sometimes it is also said to be the rotational analog of force. Okay.
Yes.
Right here.
Yes.
Generates, okay, rotational effect. You can also say. Okay.
Yes, sir.
The formula of the torque is tau is equal to R perpendicular cross F, or sometime it is written as, one second, in magnitude, it can be written as tau is equal to R F sine theta. Okay.
Yes.
This equation is in vector form, this is in the scalar form, or you can say it is in the terms of magnitude. Okay. The next point, what is the couple force? When the two forces acting upon a body at same time of in equal amount, okay, but in opposite direction, then the force acting upon the body is said to be the couple forces. Okay.
Yes, sir.
Two equal and opposite forces. opposite forces. Just like we are taking a rod like this, and at this end, the force acting upon the body along the plus x-axis, and upon this, it acting along minus x-axis. Then about the center point, it start to rotate. Are you clear or not?
Yes,
Then
sir.
such type of effect is said to be the couple force. Okay. And the net translational force. What is the net translational force?
Translation is moving from position.
Yeah.
One position to
So
another.
net translational force for the couple will be 0. I mean, F net will be
0.
F minus F, because both are acting in the opposite direction. So we can take F minus F is equal to 0. And what is the torque? The torque will be tau is equal to R perpendicular cross F. All right.
Yes, sir.
Yeah. Note it down first, please. What is the R perpendicular here? Suppose that the length of the dipole is R. In this case, you can draw a perpendicular line from this. And this is your R perpendicular, which is your R sine theta. Okay.
Yes,
This
sir.
is your line of action, you can also say. Line of action. Note it down, please.
Yes, sir. Done, sir.
All right. The next one is angular acceleration. What is angular acceleration? The formula of angular acceleration is alpha is equal to omega by t. In variable form, you can also write alpha is equal to d omega over dt. I hope you have remembered it. Newton's second law. Newton's second law in terms of rotational motion. You have already know the Newton's second law is F is equal to m into a. Sorry, just 1 second. After doing this, we will do it. What is the moment of inertia? Do you know or not?
Sir, first law of motion, right?
What is the moment of inertia?
The formula.
Yeah, no. What is the definition of the moment of inertia?
Moment of inertia when body is in motion.
It is the rotational analog of mass. When a body is moving on a horizontal, or in 1D, then the amount of substance is said to be the mass, and then the inertia is represented by the mass, and when body is rotating about a fixed point, then it is said to be the moment of inertia. Okay, because
Yes,
we
sir.
have already we have already know mass is the measure of inertia basically. Okay, mass
Yes,
is
sir.
the measure of its inertia. Okay,
Inertia.
now the next one is Newton's second law. What is this? What is the Newton's second law? You have already know F
F is equal to
m.
ma.
But for the rotational motion, F will be torque, mass will be the moment of inertia I, and linear A is your linear acceleration. For rotational, it will be tau is equal to I alpha. You can also write here tau is the torque, I is your moment of inertia, alpha is your angular acceleration. Okay.
Yes, sir.
What is your angular momentum? Do you remember?
Angular.
Yeah.
Sir, I don't remember it, sir.
Angular momentum. All of these formula are from your chapter number 7, rotational motion.
Yes, sir. I know that. Remember the term angular momentum, but I don't remember the.
Angular momentum is the rotational analog of linear momentum. Okay.
Yes, sir.
The formula is vector of L is equal to R cross P, or you can also write in magnitude RP sine theta. L is equal to. Okay.
Yes, sir.
Note it down, please. This is your R perpendicular basically. Note it down, please.
Done, sir.
All right. Now the last point is motion with constant angular acceleration. Okay. Motion with constant angular acceleration. You have already know the equation of V is equal to U plus AT. Do you remember or not?
Yes, sir. Yes,
I mean
V is equal
equations
to-
of motion. Okay.
Yes, sir. First law.
Yeah, for the equations of motion in case of the rotational motion, these are omega is equal to omega naught plus alpha t. The second one, theta is equal to omega naught t plus half alpha t square. And the last one, omega square is equal to omega naught square plus 2 alpha theta. Okay.
Yes, sir.
Here, omega naught is initial angular acceleration. Omega is your final angular.
Acceleration.
Yeah. And the last one, sorry, theta is angular displacement. And alpha is your angular acceleration. Okay?
Yes, sir.
Yeah. Note it down.
Answer.
Good. Now, our next point is electric dipole in uniform electric field. Electric dipole in uniform electric field. When electric dipole is placed in a uniform electric field, then first of all, we are going to draw the uniform electric field here. Okay. And a dipole is placed in this field. This is the dipole, which is placed into the field. This end is of plus Q charge, and this is of minus Q charge. Okay. Then what will happen? Can you tell me? This dipole is placed in a uniform electric field.
Yes,
Then
sir.
what will happen? Then
Sir, will rotate, right?
charge, yeah, positive charge start to repel. Am I right or not?
Yes, sir. Yes,
Okay.
sir.
Repel in the direction of the field.
Yes, sir, in the direction of field.
Whereas
Negative
minus charge
charge,
start to attract
opposite
from the
direction
field.
of the field.
I mean, it will be opposite direction. This
Yes,
is
sir.
your F is equal to Q into E. And this is
Yes.
also F is equal to Q into E. Are you understand it?
Yes, sir. Yes.
Suppose that this dipole makes an angle theta from the axis. And the length of the dipole we are taking as 2A. The length of the dipole is 2A. Are you clear?
Yes, sir.
Okay. Then what will be the R perpendicular? I mean, R perpendicular, you should draw a perpendicular line. I mean, component of R, which is your R perpendicular. This is 2A sine theta. Are you understand it or not?
Yes, sir.
Now, let's try to calculate all of the values which are given here. What is the net translational force on dipole?
Net translational.
Yeah. Net translational force on dipole.
So
Can
it
you tell
should
me?
net translation from 0. Sir.
Exactly.
No.
Exactly, you are right. F minus F, which is equal to QE minus QE is equal to 0. I mean, body will only rotate from their axis. With respect to this
Yes.
axis, this
It will not
dipole
rotate.
start to rotate. I mean, this,
Yes.
okay, it will never move from this position along, okay, either along plus X or in minus X axis. Are you clear or not?
Yes, sir.
And now, what will be the torque on dipole?
Torque.
Torque on dipole? You have
Sir,
already know the equation
it
of
should
the
be
torque
0.
is R perpendicular cross F. And
Yes.
you have R perpendicular is
2A
2A
sin
sine
theta.
theta into F. What is F? F
QE.
is your QE.
QE.
Okay.
Yes.
F is just 1 second. I am increasing a step here. Into F, we have R perpendicular as 2A sine theta. Okay.
Yes, sir.
2A sine theta. Or we can also write 2A sine theta Q into 2A. We can also write here. As the position of S, F, we can write here Q into 2A into E sine theta, because we have taken as F is equal to Q into E. Okay. Q into 2A is T.
Yes, sir.
T sine theta. Or sometime it can also be written as P cross E. We can write it or not?
Yes, sir.
These two are the formula of the torque. Okay. Note it down, please. Just 1 second. 1 second, please. Now, what will be the role? Okay, what will be the result of this torque which is acting upon this dipole? Causing this torque, this dipole start to rotate about their axis in such a way that, okay, it will try to align in the direction of the electric field. Are you clear or not?
Yes,
So
sir.
you can write here, torque will try to align dipole in the direction of electric field. Are you clear or not?
Yes, sir.
Note it down, please, first. Then I will discuss something about it. Okay.
Done, sir.
Okay. Harsh, it is important to remember here, okay, this whole of the explanation of the dipole in the field is especially for uniform electric.
Yes, sir. Uniform electric field.
Are you understand it or not? This is the condition.
Yes, sir.
What will happen if the field is not uniform? I mean, what will happen when the field is variable? We can also say, am I right or not?
Yes, sir.
Okay. So this all of the thing is correct for the uniform electric field only. Okay. When the electric field is uniform and your dipole is placed inside the field. Are you clear or not?
Yes, sir.
Then what will happen when your field is non-uniform? Let's try to understand it first. Okay. Electric dipole in non-uniform field. In non-uniform field. Okay. To understand it, once again, we are coming on the same diagram. Okay. When the field is uniform, try to understand. When the field is uniform, then we can say that at each and every point, okay, at each and every point, you can take a point, okay, at anywhere in whole of this region of the uniform electric field. Either you can take this point at A, or you can take at B here, you can take at C here, you can take at D here. Are you clear or not?
Yes, sir.
But at each and every point, the value of electric field is same.
Yes, sir. Uniform.
Are you clear or not? Then
Yes.
we can say this field is uniform.
Yes, sir.
Okay. In this case, the force acting upon the charge of plus Q and the minus Q will be same. Are you understand it or not?
Yes, sir.
When the field is uniform, then we can say the then the force acting upon the both of the charges of the dipole will be same. Okay. But they are in opposite in directions. All right.
Yes.
What will happen when the electric field is non-uniform? Then we can say at A, D, B, or C, we can say that electric field will not be same. Are you understand it?
Yes, sir. Yes, sir.
Your electric field will not same when the field is non-uniform.
Non-uniform.
I mean, the value of the electric field is different at each and every point. Okay. So we can say that the amount of force acting upon both of the charges will also be, okay, will also not be same.
Yes.
Hence, we can say, if you consider this F1 and this one F2, we can also say F1 will never be equal to the F2. Are you understand it or not?
Yes, sir.
Okay. I mean, it may possible that any one of these F1 and F2 may be greater and the remaining will be poor. Okay.
Poor. Yes.
Hence, we can write here the net force on the dipole. Okay. Net force on the dipole. F net will be F1 minus F2. We can say when F1 is greater than F2. Are you clear or not?
Yes, sir.
If F2 is greater than F1, then we can write F net is equal to F2 minus F1. Are you understand it or not?
Yes, sir.
Okay. Hence, we can write here Q, I mean the magnitude of charge is same for both of the end of the dipole. This charge is same for both of the end, but electric field at both of the end is not same. Are you clear?
Yes, sir.
Because the electric field at the charge of plus Q and the electric field at the charge of the minus Q is different. So we can write here QE1 minus QE2. Okay. And when a net force is acting upon this dipole, then we can say that dipole, one second, then we can say here the dipole may have translational motion or translational force. Okay.
Yes, sir.
Are you understand it or not?
Yes, sir.
May have translational force. Are you clear?
Yes, sir.
Hence, we can say this translational force will not be zero in case of non-uniform.
Non-uniform electric field.
Are you clear?
Yes, sir.
In case of uniform field, it will be zero. Okay. This is your
Yes.
first point. In second point, the torque also not be zero.
Yeah.
Okay.
It
We
will
can
be in
also write
translation.
torque also will not be zero.
Yeah,
Hence, we
because
can say
uniform will be in
again,
rotational motion.
the dipole may have rotational motion.
Yes, sir.
Dipole may have rotational motion.
Yes.
Then from this situation, we can say that the dipole have two different types of force. The first one is the translational force and the second one is the rotational force. Are you clear?
Yes, sir.
Finally, we can say the dipole start to move combinedly translational plus rotational.
Rotational.
Are you clear?
Yes, sir.
I mean, now this dipole will rotate about their axis and also move in the further direction,
Forward
just
direction.
like rolling of wheel. Are you clear?
Yes, sir.
In rolling of the wheel is rotating about their axis as well as
Translation motion is on.
it have translational motion. So you can write here your combined motion will be translational plus rotational. Are you understand it or not?
Yes, sir.
Okay, good. Note it down, please.
Done, sir.
Okay. Now, we are coming on a question. The question is noted down. In an electric dipole, of dipole moment (2 coulomb meter) is placed in a uniform electric field of 10 Newton per coulomb at 30 degree with respect to the field. Moment of inertia of dipole is 2 kg meter cube. Your question is calculate torque on the dipole. The second one is angular acceleration of dipole.
Yes, sir.
The third one is angular velocity of dipole after 2 seconds. And the fourth one is number of rotation completed by the dipole in 2 seconds. Okay?
Yes,
Note
sir.
it down, please. This is your question. Okay?
Okay.
First note it down, then we will solve it. Have you noted it?
Yes, sir. Yes.
Now, can you solve it or not?
So 1 minute we'll try, sir.
Yeah, please try to solve it. Harsh, there is a thing that I am just asking to you. Can we
Yeah.
shift this class half an hour delay? I mean from 8 IST.
5:30 to 7 Saudi time.
What is your timing from?
Sir,
What is your
like
timing of Saudi day?
India is 2.5 hours in front of us.
Sorry?
India is in 2.5 hours in front of us. Like now in Saudi, it's 6:10.
Now in Saudi 6:10.
Yes.
Okay. I mean, I am just telling to you that can we shift it 30-minute delay only.
Okay, 30 minutes.
Yeah.
Yes, sir, you can do it.
Is it possible or not?
It is possible, sir.
Okay, but not from now. Okay, I will inform you when. Okay, I required it.
Okay, sir. Like
Okay.
for the sir, for like 1 or 2 days or the whole session for 1 year?
No, for whole session, I think.
Okay.
Okay, but not
Okay.
from now. Okay, I will inform you. Yeah.
Okay, sir.
It is just asking for okay to you.
No, sir, you can do that, sir.
Now, please solve it.
Yes, sir. Sir,
Yeah.
can you solve the?
Right.
Yeah, can you solve it? So 1 minute, I'm having some confusions.
What is the given values? This is your dipole moment, which is P.
Yes, sir. Dipole moment
P
2
is of 2 coulomb meter.
2 coulomb meter.
And the electric
Net
field, I mean the
electric
value of
field is
E is 10
10
Newton per
Newton.
coulomb.
Yes, sir.
And theta is your 30 degree.
30 degree, yes. Yes.
Right. Now, what is your torque? The first of one, tau is equal to P cross.
Yeah.
Or you can also say P sine theta. Directly, I am taking P sine theta. Okay.
Yes, sir.
Yeah. What is the value of P? P is your 2.
2 cent.
Value of E is 10.
Yeah.
And this is your sine 30.
Theta is 30
Sine
degree.
30 is your 1 by 2.
Yes,
Finally,
sir.
you get 2 into 10 into 1 by 2. 2 is cancelled with 2. And the tau is equal to 10 Newton meter. Okay.
Yes, sir.
Second one. Angular acceleration of dipole. Angular acceleration, I hope you have remembered the formula is tau is equal to
Tau
I.
is equal to I. Yes.
Okay. Then what will be your alpha? Alpha will be tau over I. Tau is your 10. And inertia, moment of inertia of dipole is 2 is given here. Okay.
Yes, sir.
10 over 2, which is of 5 radian per second square. Okay.
Yes, sir.
The third one is angular velocity of dipole after 2 seconds. So we can use omega is equal to omega naught plus alpha t. Okay. Omega naught is your initial angular velocity.
Yes, sir.
0. Initial angular velocity is 0.
Yes, sir.
You can take it 0. So
Yes.
your equation will be omega is equal to alpha t.
Yes.
And alpha, what is your alpha?
5 radian.
Okay. 5. And t is your 10.
10, yes.
It will be, sorry. No. It is 2. T is given as 2 here. In this equation, t is given as 2 seconds. Okay.
Yes, sir. It will be 10, sir.
It will be 10 radian per second. Okay.
Yes, sir. I only had issue in the third one.
Sorry?
I only had doubt in the third one, sir.
What is your doubt? Tell me.
No, sir. I had doubt.
Okay.
Like,
all right.
I solved the first two and then I had doubt in the third one.
Okay. Note it down, please.
Yes. Done, sir.
All right. Good. The next one is
number of rotating.
The fourth one can be calculated as theta is equal to omega naught t plus half alpha t square.
Half alpha t square.
Which is your theta is equal to omega naught is 0.
Yes,
So
sir.
we can take it as 0 here totally. We have only half alpha t square. This is your half. What is your value of alpha? Alpha is your 5.
5 ready.
So 5. What is the value of t?
So 2
It is
seconds
2.
given here.
It will be 2 into 2 after
Yeah.
sparing it.
Yeah, 2.
It will be
Yes.
cancelled with 2. And you get theta is equal to 5 into 2 will be 10 radian.
10 raised to, yes.
Okay. But in your question, it is asking the number of rotations completed by dipole in 2 seconds. So we have already know in one rotation, total 2 pi radian is, we have totally 2 pi radian. Okay.
Yes, sir.
What will be the number of rotation? Number of rotation will be theta over 2 pi. Your value of theta is 10 over 2 pi. Finally, you got 5 over pi. Number of rotation. After putting value of pi, you can get the numeric values. Okay. But
Yes, sir.
till here, it is also correct. Are you clear?
Yes, sir.
Note it, please.
Done, sir.
Okay, good. And now the last point of the dipole is equilibrium of dipole. Okay. Or you can also say different cases of dipole. All right. Okay. Instead of it, we are going to study this case in terms of questions. Okay. Write down a question first. Discuss motion of dipole in uniform electric field. Discuss motion of dipole in uniform electric field if dipole is, the first case is, this is your parallel sign. Okay. Parallel to the field The second one is anti-parallel to the field and the third one perpendicular to field. All right. So we are going to solve it now. Just for remind you, please note it down. For equilibrium of rigid body. What is the condition of equilibrium for rigid body? It is F net is 0. If F net is 0, then the body is said to be translational equilibrium. And when net torque acting upon the body is 0, then it is said to be in the rotational equilibrium. Are you understand it?
Yes, sir.
Note it down first. Then we will try to solve these. Okay, all of these three parts, 1, 2, and 3.
Done, sir.
The first one is parallel to field. I mean, your dipole is placed parallel to field. Let's see here. This is your dipole. I mean, this is your field. Okay. Suppose that this is your field and the dipole is placed in such a way like this. This is your dipole. Are you understand it?
Yes, sir.
This is of plus Q charge and this is of minus Q charge. And now you can look at it. This is the direction of the field. What will be the angle between these dipole and the field? Theta is 0. Are you clear or not?
Yes, sir.
If the theta is 0, then can you tell me if the field is uniform, especially you can look at here. So we have already know for the uniform field, F net is 0. Okay.
Yes.
And if theta is 0, then we can say the net torque tau is equal to Pe sine theta.
Pi sine theta.
So it will be Pe sine 0. Finally, torque also be 0. Hence, we can say that the net force and the net torque acting upon this dipole, okay, which is placed in the uniform electric field, okay, parallel to the field especially, is in the state of stable equilibrium.
Stable.
Are you clear or not?
Yes, sir.
This is your stable equilibrium.
Yes, sir.
Are you understand it?
Yes, sir.
For the next case is anti-parallel to the field. I mean, your dipole is placed in such a way that your field is in opposite direction. If the field is in opposite direction,
so angle will be 180 degree, right?
the angle will be 180.
Yes, sir. Angle will be 180.
Okay. The direction of dipole is here, P. Okay, from negative to positive. Now it is your field. In this case, your theta is 180.
Yes, sir.
If the theta is 180, then we can write here what will be the net force. What will be the net force acting upon this body?
Sir,
Once
P
again, net force is 0.
Yes, sir, 0.
Okay.
Yes.
And the tau is equal to
Pe sine
180.
180.
Once
Sine
again,
180 is
tau is
minus. Sine 180 is minus 1.
minus 1, which is equal 1 second. Sine 180 is -1. Sine 90 into 90.
It's -1, right? Sir, it is -1.
Oh. 1 second. Sine 180. Sorry, I have. What is a sine 180? Where's my scientific calculator? Yeah. Sine 180. It is 0.
It is 0.
Yeah, sine 180 is 0.
And then it should cos 180 is -1. Okay, sir. Sorry, sir.
Okay. Sine 180 is 0.
Okay.
And once again, we can say it is also in.
Okay.
In the next case, it is parallel to the field. Sorry, perpendicular to the field for the third case.
Yes, sir.
I mean, this is your.
So it will angle will be 90 degrees.
Exactly. This is your dipole of plus q and minus q. And the field is in parallel to the
parallel.
dipole.
So perpendicular. Sir.
Sorry,
Yeah,
perpendicular. Yeah. Okay. Then theta is the 90 degree.
Yes, sir.
What will be the net force? Net force once again will be 0.
Yes.
And the tau is your P is sine 90 degree.
Yes, sir.
Sine 90 is 1. Hence, the torque acting upon this body is maximum.
Yes, sir.
Okay.
Yes.
Also write down in the first case, it will be minimum. Okay.
Okay.
Note it down, please. The one another case, suppose that I am just discussing to you. Please note it down first.
Yes. Done, sir. Done, sir. You can.
In another case, I am just discussing for you. Suppose that you can consider it as a case number 4. This is your field. Okay.
Yes, sir.
And the dipole is placed at some particular angle. At this angle, suppose that. Then you have already know theta is neither 0 and not 90.
90.
You can say that theta is considered as theta. Okay.
Yes, sir.
Then the dipole will try to align in the field of the in the direction of electric field. Hence, we can say the tau restoring. Do you know about the restoring force?
Yes.
A restoring force will act upon this dipole, which will try to align this dipole parallel to the field. Okay. Tau restoring will try to align this dipole. Try to align the dipole parallel to the field. Are you clear?
Yes, sir.
Note it down, please. And this is a type of unstable equilibrium. Okay.
Yes, sir.
This is a type of unstable. Okay. So